Dear students and participants on the course on railway engineering, in this lecture also we are going to discuss about the track maintenance. In the previous lecture, we discussed about the systematic overhauling, the lubrication of the rail joints, wherein the insulated and the glued insulated rail joints were discussed, and the deep screening of the ballast was taken up in terms of the manual procedures and the mechanical procedures. And finally, the lifting and the lowering of the track was discussed. In today's discussion, we will be taking up the measured shovel packing, the track circuited areas or the electrified areas of the track, and what are the precautions which needs to be taken up in these particular areas, the permanent way renewals and what is to be looked at and what is the criteria on the basis of which this renewal is to be taken up, and then the through sleeper renewal. Measured shovel packing, this is a method which is good for maintaining the fish plated and LWR tracks where the speeds are going up to 160 kilometers per hour. It is used mainly for the following works: the through packing of flat bottom sleepers, packing of the joint wooden sleepers in metal sleeper tacks. So, we have the tracks where the metal sleepers are being used, but at the joint the wooden sleepers are being used. Through packing of the turnout with wooden or the steel sleepers, or dehogging of the rail ends. This is also an issue in which this measured shovel packing has been used. Now, what is the procedure? What are the various steps which are being taken up when we go for it? First one is the measurement of voids and the fixation of high points. So, we have to identify where the ballast is moving out and is creating the voids and how many voids are there, and then accordingly they have to be filled back. And if there are certain high points which have got created, they have to be normalized and brought back to the level. Transferring those high points to the good points, longitudinal leveling, opening out of ballast, lifting and packing of the track, provision of ramps, alignment fixing, boxing and dressing, and then measuration of the joints and the checking of works in terms of the permissible limits related to the various components which are available at that location. So, in the case of this measured shovel packing, there are certain equipment which are used. We are just looking at those equipments and for what reason they are used. Canny A ball, this is used for assessing the extent of packing voids under the sleeper. So, how much are the voids? That is what it is trying to identify. Then another is a densometer. It is used for measuring the packing voids under the sleeper. So, there we assessed, yes, there are voids. Here we are measuring those voids. Then it has a tripod legs which are fixed in the ballast, and there is a dancing rod which is placed on the top of the sleeper. The shift of the friction sleeve, it helps in determining the voids under the sleeper in dynamic conditions with respect to the loadings which are going to be there on the track. So, this amount of the voids which are there is going to be defined by the shift of that friction sleeve. Then there is another equipment which is fleximeter. It is used to measure the depression of the rail under the weight of the plying traffic. So, whatever traffic is coming at the top, because of that some depression will be there in the rails. It is used along with the densometer to check the tightness of the fittings. So, whatever fittings or fastenings have been used. So, now we have a densometer, we have a flexometer, both have been used at one location. We will get the readings from both, and the difference of those readings, that will indicate the extent of loosening of the fastenings. There is another equipment which is visor and mire. These are used to measure the unevenness of the rail and for rectifying the alignment. So, two things are being taken care of here. One is unevenness, another one is alignment, and these were the two of the parameters. If you remember, when I started discussing about the maintenance of the tracks, we have considered them along with twist and gauge. Visor is a type of a telescope with a magnifying power of 12 and is supported on a stand which is fixed to the rail seat with the help of two clamps. And Meyer is a staff which is bearing 5 graduated scales in mm. It can be fitted to the rail head using the band clips. Now, using these two things, we can identify the condition with respect to unevenness and the alignment. Then gauge cum level, this is used to measure the gauge and the cross levels. This is a spirit level which is 200 mm long and having a sensitivity of 2 minutes 30 seconds and is used to measure the cross levels up to an accuracy of 1 mm. Then packing shovel, this is used for placing the stone chips over the full width of the sleepers under the rail seat. It is around 1 meter long. It is having a pan to collect the chips and the throw of the blade is 100 mm for a broad gauge track. So, depending on in which particular track it is being used, the sizes are different. Then non-fringing track jacks. Now, these are used for lifting the rails. But why this name is non-fringing? They are being used in such a manner that even if they are used to lift the rails and now there is a requirement that the train is coming or arriving, is approaching on that track, without little manipulation, this can still remain there in position because there is no such protruding arm of this particular jack which is going to create an hindrance with respect to the movement of the wheel and flanges over the top of the rail. So, there is no requirement of removing the jack and that is the reason that is being defined as infringing track jacks. These are designed for safe working load of 5 tons and a maximum lift of 200 mm on a broad gauge track. Now, let us move into the circuited areas or the electrified areas. What are the precautions which needs to be taken here? The two rails on the track, they should not be touched by any tool or a metal object that may cause the short circuiting. It should not happen that we have put something which is going across the rails or we are going across two rails in line and then it may create a short circuiting here. All gauges, levels, trolleys which are used in the track circuited length should be insulated. The steel or CI pipes which are placed under the track and these steel or CI pipes may be carrying wires or some other thing depending on for what particular reason they have been provided. They should be sufficiently below the rails so that they are not creating an impact in terms of a short circuiting or interference with the tracks. Before taking up the maintenance, all S&T, the signals and telecommunication systems or electrical installations which may interfere should be removed. Use of steel tapes is also avoided in these particular areas. The proper drainage needs to be ensured on tracks as well as in yards or wherever there is a possibility of a water getting accumulated. Washable concrete aprons, these shall be provided on platform lines in the track circuited areas so that water is not going inside and it flows over the top of it and then it is being taken in the lined drain and then finally is being drained out at some other location. The ballast must be kept clean throughout the track wherever the circuited sections are being provided and the care should be taken to see that the minimum ballast resistance per kilometer of track should not be less than 2 ohms per kilometer in the station yards and 4 ohms per kilometer in the block sections. So, this is one another criteria. Then on the pre-stressed concrete sleepers tracks, availability of the insulated liners up to a minimum level of 97% shall be ensured. Any hole which is drilled in the rail for providing S&T fixtures should be at the neutral axis of the rail and then should be chamfered. In case of curves in track circuited areas, the effort should be made to keep the inner rail as positive rail. If you remember in the when we were discussing about the track circuits, so there the rails were provided, but then the positive sections were provided in this manner, and then at some locations they were connected together, in some locations they have been connected in this form, or there was a jumper connection also. So, this positive sections is what we are talking. In the case of electrified areas, no work shall be done within 2-meter distance from the live parts of overhead electrified area. The section concerned should be isolated and as well as earthed, and that has to be done on the day and at the time when this maintenance is going to be taken up. But before taking up this maintenance, the date and time has to be communicated to the telecommunication or the electrical wings, and a permit to work needs to be taken. Then any branch of tree which is coming within 4 meters of the live conductor needs to be trimmed or cut off, and this has to be done periodically, because after some time again this will come to that particular area. No fallen wires or wires shall be touched unless the power is switched off and the wires are suitably earthed. In case wires drops at the level crossing, then the gatekeeper who is there should immediately arrange to stop the traffic on the track. Precaution be taken to prevent possible damage to the traction underground feeder cables, because now we are working with the electronic system, so everything is going underground also, and these are provided very near to the running lines. So, it should not happen that we started working and because of that some of the things have been cut. Vertical and horizontal clearances of the wires, they also needs to be taken care of with respect to the center line of the track. No tool or part of the body should come within 2 meters of the overhead electrification. Then while doing maintenance of the track or the removal of the fish plates or the rails, temporary jumpers shall be used for bridging the gaps. These jumpers were also discussed when we were talking about those track circuits with respect to the double lane systems, wherein they were connected by a positive and negative and the relay and the free ends. So, here this is one sort of a jumper being shown. The temporary connections shall be made in case of the track renewals, defective or broken rails or loosening of the fish plates. To omit the possibility of shock which can build up due to the potential which is coming from the induction in the metallic bodies which are very nearer to the OHE, the metallic structures shall be bonded together and earthed, because this is a induction effect. So, if this induction effect is there and there is a possibility of some potential getting built up, then it is required that it needs to be earthed and that should flow down. While unloading the rails, care should be taken to ensure that rails do not touch each other to form a continuous metallic mass of length more than 300 meters. So, that is the maximum length which can be allowed, beyond that it should not be taken. In case electrically hauled train is within 250 meter, the staff shall remain clear of the track and avoid contact with the rails. But at that time the circuit is already in process, and any touching or any such thing can create a problem in terms of short circuitings and may be a problem even in terms of a shock as well as a disruption of the traffic. Now, normally all catch sidings except those which are sanded shall be kept alive. In the case of the sanded catch sidings, the rail shall be kept clear of the sand for a length of 21.5 meters beyond the section insulators in the overhead lines. So, when these sand linings are provided, so for a certain distance of 21.5 meters, the whatever rails are provided, they should be kept clear of the sand. The switches controlling the sanded catch sanding shall be kept in the neutral position. These shall not be made alive when an electric engine or a single or multiple unit train or any vehicle coupled thereto are standing in the sanded tracks. Okay, otherwise again the problems with respect to the flow will be there. Now, when we talk about this permanent way renewals, there are different type of renewals which can be there. They are also being categorized by primary and secondary renewals. Complete track renewal, that is CTR, again can be primary or secondary. Then there can be through rail renewal, which is TRR. So, this is primary and secondary, that means it is a TRRP or TRRS. Similarly, there can be through sleeper renewal. There is a through turnout renewal, which is defined as TTR, through fittings renewal, which is defined as TFR, through weld renewals, which is defined as TWR. In the case of bridge replacement renewal, it is TBSR, or for ballast renewal, it is TBR. So, these are the various codes which are in use on the Indian Railways, and if any of such code is there, then accordingly the people working will be understanding what needs to be done. So, what is a primary renewal? The primary renewal is in which only new materials are used. So, all new materials will be brought in and will be placed in position, and finally, whatever the various steps are required which needs to be taken up will be taken. The secondary renewals, in this case the renewals is using the released but serviceable materials. So, any such rail section, sleeper or any other thing which has been released from any of the track, but still it has a serviceable life. So, that can be used here, and in that case it is defined as a secondary renewal. There is another terminology which is scattered renewals. These scattered renewals are what? Here the unserviceable rails, sleepers and fastenings, they are replaced by the identical sections of the serviceable and rails or sleepers or fastenings, and nearly the same vintage track components in the isolated locations, and not more than 10 rails or 250 sleepers in a gang beat in a year. So, this is the extra restriction which is being placed here. So, it is talking about the replacement of the unserviceable parts, but then when we are doing the replacement, obviously the identical sections have to be identified which are having serviceable life, and they are going to place there, and they are being done in the isolated locations, not in the continuous track condition. And there another thing which it says is that at a time in a year, not more than 10 rails or not more than 250 sleepers are going to be changed in a one gang beat. So, we talked about the sectional gangs, we talked about the mobile maintenance gangs. So, that is where they will be taking care of these type of aspects. Then such renewals are part of the normal maintenance operations. Another one is a casual renewal. So, in the case of casual renewal, again whatever unserviceable parts are there, components are there of a track, say rails, sleepers, fastenings, they are going to be replaced by identical sections, the same way as we talked in the case of a scattered renewal, and they are being done with the same vintage track components in isolated locations, but here we are talking in a continuous form, not on the small stretches. Okay, so it is locations of continuous but small stretches, that is what is being taken. Sorry, I said not small stretches, that is not the case. This is not a part of normal maintenance operation. Then through fitting renewals, in this case only liners or GRSPs or CGRSPs are renewed without replacement of the ERCs. So, ERCs are the elastic rail clips, and these are rubber sole pads, the grooved or the composite grooved rubber sole pads that we have discussed when we discussed about the various types of fastenings. Then factors which are governing the renewal, the incidences of the rail fractures or the failures, if they are there, then we have to go for a renewal. There is a high wear on the rails which is going beyond the permissible limits. The maintainability of the track to prescribed standards. Expected service life in terms of GMT of traffic which is being carried on the track is already over, or there is a plan based renewal that slowly we are upgrading the track, so that schedule has been created and accordingly the renewal has to be taken up. Now, what are the incidences of the rail fractures or failures which are necessitating the renewal of the track is what we are looking here. A spate of rail fractures on a particular section having 5 withdrawals of rails per 10 kilometer in a year due to the fracture or due to the flaws which are being detected by the ultrasonic flaw detectors falling in the category of IMR, that means immediate replacement, will have priority while deciding the rail renewals. So, we have used the ultrasonic flaw detectors and we have found that whatever defects are there, they are falling in the category of IMR, and there are 5 withdrawals of the rails in 10 kilometer in a year, and that is happening again because of the defects or because of the fractures or the failures. Then in those cases the renewal is to be taken up. In case the rail failures are at fish plated or welded joints and they are predominant, and cropping with or without welding can be considered. So, usually this is the first step, because if anything is happening at the end and we can remove that end, we can crop it and we can put another section there. We have discussed about this particular aspect also previously. We are putting that new rail section, the rail length has been defined. Kindly check it whether it was 3 meters or 6 meters. Then TRR is allowed in locations of track where the more than 30 defective welds per track kilometer are existing. If this much amount of failures are there, then in that case the TRR is being used. Okay, so it is a renewal trained for renewal conditions. Then wear on rails, the criteria. Limiting loss in the rail section is one criteria. How much weight has reduced. So, if it is 6% in the case of 52 kg per meter rail section or 7% in the case of 60 kg per meter rail section, then in that case we have to change it. Then corrosion is another aspect which happens in the web or the foot of the rail section, and if it is beyond 1.5 mm, then that creates a condition of a renewal, or the existing of the corrosion pits on the underside of the foot and the liner biting on the foot. So, if that is also happening, then also the renewal is to be taken up. The vertical wear, which is measured as a difference between the height of the new rail and the height of the worn out rail. Say if you see on the diagram which is being shown on the right hand side, this is the new rail profile, but after some time it has come to the worn out profile. So, there is a difference in this height, and this difference in the height is being talked as the vertical wear. So, if this is beyond 13 mm on a 60 kg per meter rail and beyond 8 mm on a 52 kg per meter rail section, then in that case also it creates a condition where the renewal of the rails can be taken up. Regarding the lateral wear limits, now these lateral wear limits, if you see on the diagram being shown on the right hand side, the initial condition of the rail was like this. So, this was the rail head, but then the wear has taken and now it has become in this form. So, there is a lateral wear which is occurring on the side of the rail head, and this difference between the two profiles at a depth of 13 to 50 below the top of the rail is what we are taking as a criteria. So, what is the value? In the case of the curves for A and B roads it is 8 in the case of C and D roads it is 10 Whereas on a straight section again for A and B roads it is 6 whereas for C and D roads it is 8 So, 2 difference is there between the curve and the straight profiles related to the lateral wear limits. Now, let us talk about the maintainability of the track to prescribed standards, poor running quality of the track in spite of extra maintenance. Means again and again you are doing the maintenance, you are putting the more of the labor so as to do that maintenance, but still the quality has not been improved and it continuously keeps deteriorating, and again you have to go and do the maintenance. So, in those particular situations the way renewal has to be taken up. Disproportionate cost of maintaining the portion of the track in safe condition. Lot of amount has to be invested so as to bring back the track to the normal conditions or a good condition or a safe condition. So, this cost is also needs to be considered. How much is that cost? Up to certain level it is okay, but beyond that if it is going and again needs to be done, then this is not an advisable situation and we should go for a renewal. The condition of rails with regards to hogging, battering, scabbing, wheel burns etc., such as the excessive corrugation of the rail. So, any of such things which are appearing, in that case also we will go for the way renewal. Another criteria can be on the basis of the service life, and the service life is always talked in terms of the total GMT, the gross million tons of the traffic which is coming on the track. So, if we take the 60 kg per meter rail, in the case of 60 kg per meter rail it is 550 GMT if 72 UTS rail section is being used. If 90 UTS section is used, then in that case it becomes 800 GMT. Whereas, if you are taking a 52 kg per meter rail, in that case the values will be lower and becomes 350 GMT for a 72 UTS rail section and 525 GMT for a 90 UTS rail section. So, if you have a 52 kg per meter rail and 90 UTS rail section and 60 kg per meter rail with 72 UTS section, they are more or less having the similar service life. Now, in case of the bridge proper or on the approaches, and when we are talking about the approaches, we are taking 100 meters on either side of the bridge. Of all of the important bridges, such as the major bridges where the height of the bank is 5 meter or more, all tunnels as well as their approaches which are again 100 meters on either side. The GMT values which have been considered here at the top for 52 kg per meter rail and 60 kg per meter rail section, they can be reduced to 50%. So, the conditions are being stipulated here. Now, plan based renewals as per the predetermined plan with the objective of the modernization on the selected routes in the quickest possible time. This can be done even if it is premature renewal. The renewal of the special track components like SEJs, glued joints etc. In case such components have deteriorated to a level where they are not able to serve their desired purpose, then also obviously we have to change them. Now, through sleepers renewals, the concrete sleepers will be considered for the replacement and renewal. Even if we are having the metal sleepers or any other type of the sleeper which has been used, but now the emphasis is that all of the track should have slowly the concrete sleepers. But these concrete sleepers are going to be replaced. Now, what are the conditions? That if they have developed the notches which are more than 3 at the rail seat location, because as soon as it is more than 3 that notch, then the loosening will be there, and in this case it is not possible because of the type of material which is being used in the sleeper that we can rectify it. their inserts are broken or they have got elongated. So, in the case of concrete sleepers, if you go back and try to remember what are the type of the fastenings which were used. So, one fastening was insert. They are not able to provide required toe load. So, the fastenings which are provided wherein the sleeper and the rail has been connected together, say the clamps are provided and the clamps are putting a toe load on the foot of the rail section if that toe load is not as per the required conditions. Then the sleeper themselves they have broken, or there can be any other reason due to which the gauge and the levels cannot be held. So, in those cases these concrete sleepers are going to be renewed. So, they have to be changed. Now, through sleeper renewal should be considered if the percentages of such sleepers exceeds 20% in a patch. So, whatever the length is being taken in that particular length, whatever number of sleepers are there, say if 100 sleepers are coming in a certain length, then if it is more than 20 sleepers, we have to go for a complete renewal here. On girder bridges, when several sleepers are defective, renewals should be carried out for the full span. These concrete sleepers on plain tracks, the criteria is 2000 GMT, a very big value here, or 35 years, whichever is earlier, or otherwise if the condition prevails, whatever such conditions which we have discussed before, on the basis of that also we have to go and make a change, we have to replace the things. Here also the values which have been talked here, they can be reduced by 50%. Subjective, we are talking about turnouts or the CC aprons or the curves which are sharper than 6 degrees, or SEJs or the gradients which are steeper than 1 in 100, coastal areas, station yards, as well as the approaches to those areas. So, in such areas the value can be reduced. Now, the renewal of the track fittings, if we are talking about GFN 66 liner which are being used on the plain tracks, the criteria is 200 GMT of the traffic or 4 years, whichever is earlier, or otherwise the condition basis. Similarly, in the case of the metal liners on the plain tracks, the criteria is 300 GMT or 8 years. This on the condition basis will remain every time, because that has to be seen that if something is happening before 300 GMT or 200 GMT or 4 years or 8 years, we have to replace them. In the case of elastic rail clips on the plain tracks, the criteria is 300 GMT or 8 years. Again, all of these criteria, they can be reduced by 50%. Subjective, we are on turnout, CC aprons, curves sharper than 6 degrees, SEJ gradient sharper than 1 in 100, coastal areas, station yards, their approaches, that means the same which we have discussed previously. Then if there is a GRSP on the plain track, the criteria is 200 GMT or 4 years of the condition. If it asks CGRSP, in this case it is 300 GMT or 8 years. Again, for the specific conditions, these values which are being talked here can be reduced by 50%. So, that's how we close now this particular discussion. What we discussed was the measured shovel packing, then the various maintenance precautions which needs to be taken when the track is circuited or there is an electrified area on the track. What are the criteria when the permanent way renewals needs to be taken up, as well as the through sleeper renewals also needs to be taken up. Then we also discussed about the criteria when the various types of fastenings which have been used on the sleepers needs to be removed and to be replaced. Thank you. We will be meeting in the next lecture. Till then, bye.